In this video, we'll go through the steps to show how to calculate forecasts from an AR2 model. Recall that in our last video, we looked at the forecast for an AR1 and showed how to calculate that using real data. We're going to do the same thing here for an AR2. To get us started, let's review that formula for the AR1 forecast. It looks like this: x hat of T naught of L. And remember what that means. That is the forecast L steps ahead of this T naught, where T naught is the forecast origin, equals phi1 times x hat of T naught of L minus 1, that's the lag before it, plus this x bar term. So that's the formula for the AR1 forecast. Now, if we generalize that to the ARP, the forecast formula looks similar but bigger, and what happens is it just gets extended by out to p terms instead of just one term. In other words, it looks like this: x hat of T naught of L equals phi1 of x hat of T naught L minus 1, just like it was before, plus then it's this linear combination of previous forecast terms. So that's the first piece of it. And then plus this x bar term, just like it was in the past, but instead of phi1, it goes all the way out to phi sub p. So not a surprising formula. That sounds consistent. And then if we want to take that to p equals 2, like we do in our example, then we will let p be 2, and you'll see that we end up with is phi1 times x hat of T naught of L minus 1 plus phi2 times x hat of T naught of L minus 2, and then plus the x bar term. So this is the formula that we're going to need in order to do the example that we have next. So here's the example. Suppose that we have a realization of 75 data values from this AR2 model: 1 minus 1.6b plus 0.8b squared times xt minus 50 equals a sub t. And suppose that after you generate that data, you find that x bar is 29.4, the 74th data value is 27.7, and the 75th value is 23.4. You'll see in just a minute why we needed to note those three terms. Now, before I go any further, let's talk about the fees from this model. Since we know the model, we know that the fees are 1.6, phi1 is 1.6. Remember, we changed the sign. And phi2 is equal to negative 0.8. Okay, those are going to be important as well. And let's suppose that what we want to know is the following: what is our forecast of data value 76? There's our question. So really what we're asking ourselves in the notation that we've discussed just recently is we want x hat of 75 of 1. As I said over here, that is one step ahead of the forecast origin of 75. Well, what we should do is trust this formula over on the left side. So we will do that. So it's first of all going to be phi1. Well, we know that phi1 is 1.6 times x hat of T naught. Well, we know that T naught is 75 of L minus 1. Well, our L is 1. 1 minus 1 is 0. So that's what that should be. Plus, now we're at phi2. Phi2 is negative 0.8. times x hat of T naught, which is 75 again, of L minus 2. Well, again, L is 1, so 1 minus 2 is going to be negative 1, plus x bar times 1 minus phi1. Phi1 is 1.6, minus phi2, that's negative 0.8. So that's a plus plus. And that's what we have so far. Looking pretty good. Let's fill in some more blanks here. We have 1.6 times, now what is x hat of 75 of 0? Well, really, that's 0 steps ahead of 75. So in other words, it really just means x75, which we have. So we know that that's 23.4. So I have 1.6 times 23.4 minus 0.8 times x hat of 75 of negative 1. Well, what's x hat of 75 of negative 1? Well, it really means one step behind 75. So really it means x of 74, which is also a known data value, 27.7. So that's what goes in here. Plus x bar we know is 29.4 times 1 minus 1.6 plus 0.8. And now we're just a calculator step away from having our answer. And that's going to give you 21.2. And that is our forecast for the 76th data value. Now, I'll let you practice. I'm going to, suppose we want to know the forecast of x77. How would we get that? Well, I'm going to give you the answer and let you work to get that answer. So really what we have is x hat of 75 of 2. So our L is 2 in this formula. So I'm going to say dot, dot, dot. You try this, and you should get 21.1. Interestingly close to x of 75, or the forecast for x76, I should say. And then let's do one more for practice. What about x78? What if we're looking for the forecast for the 78th data value? That would be x hat of 75 of 3. And again, you try that, and hopefully you'll get 22.7. And if you can do those three, you can do a bunch of them. And also, not only that, we've talked about how to calculate forecast for the AR1, and we have also done the same thing for the AR2. And you can tell by this general formula that if you can do those, you can extend that to as far as you'd like to go. But remember, the best way to do it is to let R do it through the TSWGE routine. But we still think it's a good practice for you to know where things come from and be able to calculate it yourself. And then after you do that once or twice, then let R do it from then on out.